Hello students and friends. Today I'll discuss about the intermolecular force from the unit number 5 of chemistry class 11 CBSE syllabus. Today's class number is 094. What is the intermolecular force? Intermolecular force are the force of attraction and repulsion between the interacting particles. The interacting particles may be atoms or may be molecules. So when it is the attractive intermolecular force, then it is called van der Waal force. One thing we have to remember that intermolecular force does not include the electrostatic force. Electrostatic force exists in between the two oppositely charged ions. And this force that holds atoms, a molecule together, covalent bonds. That means intermolecular force does not include the electrostatic force and the force behind the forming of covalent bonds. First, we'll see the van der Waals force. Van der Waals force vary considerably in magnitude, and it includes dispersion force or London force, dipole-dipole force, and dipole-induced dipole force. So, category for the van der Waals force is three types in different magnitudes. First is the dispersion force or London force. Second one is the dipole-dipole force. And third one is the dipole-induced dipole force. A particularly strong type of dipole-dipole interaction is hydrogen bonding. So, hydrogen bonding is an example of the dipole-dipole interaction, which is very strong in nature. Attractive force between an ion and a dipole are known as ion dipole force, and this also does not include in the van der Waal force. So to remember that whatever the attraction force between the ion and dipole, it will not considered as van der Waal force. First, we'll discuss first type of van der Waal force is the dispersion force or London force. When the atoms and nonpolar molecules are electrically symmetrical and they have no dipole moment because their electronic charge cloud is symmetrically distributed. So in atoms and nonpolar molecules, all electrons are symmetrically distributed, and in that case the no dipole moment in these atoms or nonpolar molecules. But a dipole may develop momentarily, and that means for a moment, even in such atoms and nonpolar molecules also. Now, so example we'll see. To consider the right side this figure. So first figure, if you see for the atom A and atom B, the symmetrical distribution of electric charge. You can see the in this case this is the symmetrical distribution of electronic charge for atom B, and for A also same distribution of the electron clouds. But in the second case, for a moment, there is the charge. What are the positive charge for atom A? It is extreme left side and electron cloud is right side. That is momentarily this is the dipole. That is negative tendency in the right side. It is there in atom A, and left side the positive charge. That is nucleus is there. And similarly for atom B also, left side it is the positive charge nucleus and right side the electron clouds. And in the figure this C also you can see when the right side is the nucleus and left side is the electron clouds for both atom A and atom B. So these atoms and atoms B for this figure B and C is momentarily dipole in nature. So what is the result? The result is that the development of instantaneous dipole, whatever I told, both case, because the electron density is distorted, and these are the temporary dipoles of atom A and atom B. Then these two will attract each other, because this is the positive and this is the positive and this is negative and this is negative. So this negative cloud will be attracted by the atom A positive charge, and in the above case figure number B, the atom A's the electronic cloud will be attracted by the positive charge of the atom B. So this atom A and atom B will attract each other due to this temporary dipoles of these two atoms. For molecules also, non-polar molecules also, same thing will happen. So this force of attraction between two temporary dipoles is known as the London force or dispersion force. So whatever the force of attraction between this atom A and atom B, for both cases, figure number B, figure C, this is called the London force or dispersion force. Now, second type of van der Waals force is the dipole-dipole force. So what is dipole-dipole force? Dipole-dipole force acts between the molecules possessing permanent dipole. In the first case, London force or dispersion force, you have seen this is the temporary dipole. But for when the dipole-dipole force will happen, then molecules should have the permanent dipole. And then ends of the dipoles possess partial charge, and then charges are shown by Greek letters delta. This is the common nomenclature, and this partial charge are always less than the unit of electronic charge. And these polar molecules interact with neighboring molecules. Now we'll see the example. Right side is the example is there. The molecule is the hydrogen chloride, HCl. So H is comparatively electropositive than Cl. So the cloud, electron clouds around this molecule is partially will move to the comparatively electron negative Cl atoms, and above the H plus the delta positive charge, which is a positive in character, will happen, and similarly for Cl delta negative, and this is called the permanent dipole nature. That's why you have written the delta plus above the H plus and delta minus above the Cl atom. And in this case, whatever the another molecule, that means two molecules of the HCl, they will arrange in such a way that Cl having the delta minus charge will attract the H with delta plus charge of another molecule. So these interactions is stronger than the London force, but it is weaker than the ion interaction because both are not completely ionized. So dipole-dipole force is stronger than London force, but it is weaker than the ion interaction. Then the attractive force decrease. When it will decrease with the increase of distance between the dipoles, because if this distance will increase, then this attractive force will decrease. So the dipole-dipole interaction energy between the stationary polar molecules, as for example, in solids, is proportional to the 1 by r cube. R means it is this distance, and that between the rotating polar molecules, these are the rotating polar molecules. So in this case, this distance is r, then this dipole-dipole interaction energy in these rotating polar molecules is the proportional to 1 by r to the power 6. Now, what type of van der Waals force is the induced dipole force. This type of attractive force operates between the polar molecules having permanent dipoles and the molecules lacking permanent dipole. That means when the attraction happens between the permanent dipole and less permanent dipoles molecules, then it is called the dipole induced dipole force. Here to remember induced, that means this dipole who has the permanent dipole in character, this will induce some dipole character to the other molecules. We'll see the example. This is the example. In this case, this molecule AB is the permanent dipole, that's why delta plus, delta minus. And this is the non-polar molecules. Apparently, it doesn't have any dipole. But in this case, whatever the electrons around the B, this will induce some dipole character. How? Because if electron will pull there, then these electrons, this side, whatever the electrons for the second non-polar molecule, this will move further away to the right side, and then these non-polar molecules will be induced to form the dipole. So that's why it is the delta plus and delta minus. And in this way, an induced dipole is developed in the other molecule, this molecule. In this case also the interaction energy is proportional to the same previous one, that 1 by r to the power 6, where the r is the distance between the two molecules. This is the distance. This distance is called the r. So induced dipole moment depends upon the dipole moment present in the permanent dipole, because if it is more strong dipole molecule, then it will affect more to the other non-polar molecules to form the dipole, and also the polarizability of the electrically neutral molecule. High polarizability increases the strength of attractive interactions, and in this case also cumulative effect of dispersion force. Dispersion force we know. In the first case we have given the example. This dispersion force and dipole induced dipole interaction exist, and both will create the cumulative effect to form the dipole induced dipole force. I hope that you understand the three types of van der Waals force, and it will be helpful to write the specific answer of the question based on the van der Waals force, how many types of van der Waals force is there, and each one you describe this type of question, you can answer very correctly. And thank you so much for watching this class.